So problem 2 on homework 9 states that obtain an expression for the current density of TMN modes on the conducting plates of a parallel plate waveguide. Do currents on the opposite plates flow in the same or opposite directions? So the way we go ahead and solve this problem is we'll first write down the equations for TMN modes. It's the same set of equations that we used in problem 1. Um, the equations are basically the field equations. So Ez component is equals to a n sine n pi y by b. We don't have to write the time domain part, so I'll skip the cos omega t minus beta z problem. So we'll just write it in the phasor form. So Ey is equals to gamma by h a n cos n pi y by b, and finally hx is going to be j omega epsilon divided by h a n cos n pi y by b. Okay, so these expressions are the same as the ones that we used in the problem 1. Only if you want to find the time domain equivalents, you multiply it with e to the power j omega t and take the real part, you'll get the exact expressions used in the first problem. Now once you have this, all that you have to do is find the surface current density. So surface current density is given by, we know that surface current density is given by Js is equals to the surface normal for the plate cross product with the H field. Okay. Okay. Now we have two surfaces. If this is the upper plate, okay, if this is the upper plate, and we can see that the upper plate has one direction, the lower plate has an other direction for its outward normal. So if you say this is ay, then this will be minus ay. Okay, now if that is the case, then so let's say j surface lower is going to be ay cross h at y is equals to 0. Okay, does that make sense? Y by b equals to 0. Okay, this is the formula for, if we assume the y, if we assume the y coordinate is in this direction, so then this will be negative and this will be positive. So let's go ahead and write it out. So a y cross, so how would that be written? Once we have a cross product, we'll have to do matrix multiplication. Ax, Ay, Az, so 0, 1, 0, and divided by again. So h has only a an x component, so all of this is going to be 0. So what does it come down to? It comes down to ax is going to be 0 minus ay is going to be 0 plus az is going to be minus hx. Okay, therefore JSL is equals to AZ minus HX when y by b is equals to 0. So that's going to be equal to minus AZ j omega epsilon by h an cos n pi y by b is equals to 0. Okay, so when that's the case, it is going to be minus j omega epsilon a n by h, because cos 0 is equals to 1. Okay, so the current density on the lower plate has a negative z direction. Okay, now let's see what happens to the positive z direction. It's going to be uh, the same formula as earlier. So we will do the matrix multiplication again. Ax, ay, az, 0, minus 1, 0, and h is going to have hx, 0, 0. So we're going to be left with az hx as a consequence, because there is an additional negative sign here. Just remember that we are using this sign convention. You could pretty much use any sign convention you want. You can assume the upper plate has positive ay and lower plate is negative ay. It will do. All that is important is you follow the same consistent method all along. Okay, so AZHX. So if that's the case, then JSU upper, current density upper, is going to be j omega epsilon by h a n cos, sorry, when it's upper plate, right, this is going to be 1. So that's going to be an n pi y by b is equals to 1. Okay, so that's going to be equal to j omega epsilon by h a n cos n pi az. Now cos n pi, if n is equals to 1, this is going to be cos pi is going to be equal to minus 1. If n is equals to 2, it's going to be plus 1. And if n is equals to 3, it's going to be minus 1. So we see a trend here, okay, which basically says it's going to be minus 1n. So if n, so cos n pi is equals to minus 1 to the power n, where if n is odd, you will have a negative number. If it's even, it's going to be a positive number. So JSU upper is going to be j omega epsilon naught by h a n minus 1 to the power n az. So all that it's saying is that no, yeah, all that it's saying is that we will. So all that it's saying is that the current density on the upper plate is changing its directions with the mode of operation. So we know that JSL is going to be j omega epsilon by h minus a n a z. Okay, so am I right on this formula? Right. So the, if let's say on these plates, if this is the positive z direction, okay, and this is the negative z direction. So the lower plate, on the lower plate, you will see that current, on the lower plate, you'll see that the current flows in this direction always. But in the upper plate, it depends on the mode. If it's an odd mode, let's say if it's TM1, it'll flow in the negative direction. Okay, if it's TM2, then it will flow in the positive direction. So it changes with the mode. That's about it. Thank you. So